Okay, on the homework that you're turning in today, beneath the heading, quiz. Here's the quiz today. So beneath the heading, here we go. So it says, K is the constant rate of change or the slope of the graph, right? So I want you to say, tell me what the meaning of this value is. How have we come to understand it? What does it tell us about how the two quantities change together? Okay? A sentence or two about the meaning of this value K. That's the constant rate of change and the slope of the graph. So what's it about? What's the meaning of it?
This goes on our homework, right? The quiz goes on our homework.
It goes beneath the heading. Okay. Beneath the heading on homework. Okay, one more minute. Okay, let's pass them up. So you put it all together, the questions, and the piecewise function. Okay. Is it Megan? What was your thinking on this? So, what did you think about this? You kind of tailed off there again. Try it again.
I said K is how many times greater or smaller the change in
You said how many times greater or smaller the change in x is to the change in y? One place. Okay, I want you to do where's C? In the wrong wrong place. You gotta get this right. Okay. Fold it, open side to the right. Open side to the right. Okay, Nicole, did you hear what Megan said? What did you think about this? She said how many times greater change in x is to the change in y?
It's kind of what I put it, it's just how much, I put how much one unit is changing compared to another unit.
How much one is changing compared to another unit?
Put in relation to another, in relation to.
Okay, so what about Megan's? Ed and Ed?
I put that K is kind of like the scaling.
Okay, hold on a second. I'm not asking what you put.
Oh.
Megan said it's, say it one more time.
K is how many times greater or smaller the change in x is relative to
How many times greater or smaller the change in x is relative to the change in y? Corey.
They said not the change in x, but also the difference between x and y, not the changes in x and y.
Not the changes, but the differences. So it's almost perfect. That's not quite right about it.
X and Y.
What's your name?
Daniel?
Daniel.
I believe it's the change in Y.
What do you think?
Yes.
Yeah, so it was perfect, except it's a measure of the size of changes in y relative to changes in x, and you just had them flipped. Okay. So other thoughts about it. Other thoughts about what it. There's other things to talk about. The meaning of k. So you were going to say what you said.
Saying that it has kind of become the scaling factor of changing x to changing y, or is that right? No, changing x to changing y.
Okay, can you say more about that? So what do you mean?
Like, if you're looking at changing, like, if you quantify the change in x,
Okay.
and then you multiply it by that k value, or using that as the scaling factor, it'll become the change in y.
Okay. Yeah, so it's not really a scaling factor because it's going to give us a new type of quantity. So instead we call it like a constant multiple. So it's the same constant no matter what your change in x is. You're right. Multiply by that change in x, it will give you the corresponding change in y. So it's not. So it's we call that a constant multiple. Okay. Lauren.
I was just going to say that y changes k times as fast as x.
Well, she says y changes k times as fast as x. DJ, you like that? Yeah? Okay. Is that true? Yep. Other things that you said? Daniel, what did you say?
I said x changes, what you said, k times as fast as y, or y changes x. I can't remember how I worded it, but k times x.
Change in y
Yeah,
is
change
k
in y.
times the change in x.
Yeah.
Does y equal kx? Maybe, but not necessarily. It's changes, right? It's the proportionality, the constant multiple of proportionality for the changes, not just y and x.
Changes in y, only for the changes in x equals k.
Right, so that's how you calculate it. You calculate it by the change in y divided by the change in x. So then what does it give you? What's the number mean?
The slope. That's like, it gives you like the relationship of how they change together.
How they change together. Christina?
But it expresses a numerical relationship between x and y.
Okay. So what relationship? So what does the number mean?
So you can also calculate whether or not it has a positive relationship or a negative relationship.
Okay. So if it's positive, they're both increasing. If it's negative, y decreases as x increases.
So like the proportional relationship
So what is proportional?
changes in y.
Right, the changes in y are proportional to changes in x. Still one more kind of major theme that we said k was that no one's mentioned yet. Or mentioned directly anyway. That number k is? All right.
Relative size
What relative size of what?
of x to y.
X to y.
Is it x to y or y to x? Is it y to x?
Okay, relative size?
It's a relative size of the change of x to the change of y.
Relative sizes of change of x, change in y. Stanley.
That's backwards, right? It's changes in the relative size of changes in y to changes in
It's the relative size of changes in y. So it's the size of the change in y relative to the size of the change in x. So it's the relative size of change in y to change in x. Just think of how you calculate it, right? Corey said it's delta y divided by delta x. So really it's a measure of delta y. That's in the numerator, right? It's a measure of delta y in the units of delta x. So we're measuring delta y in the units of delta x. So it's the relative size of changes in y to changes in x. Okay, just going to keep practicing. I think we're getting better, though. We're getting better. Okay, so let's take a look at the piecewise. Any questions or further comments? So here was your assignment, was to come up with the piecewise definition of this function. Okay, so let's do it. We'll do it on graphing calculator. And so I want to remind you that you can use character strings or words to be single constants by doing the backslash. So if you do backslash, and so we'll name this function piecewise. So okay, and then you hit backslash again. And when you hit backslash again, they disappear, and now it sees that word piecewise as a single parameter, as a single variable. And notice it's equal to 1. Okay, but I'm going to use that as the name of my function. So if I want to set up the function that way, I'm going to, how do I get my parentheses for a function? Control 9. Okay, and we'll use our local variable x. So when you're defining a function, make this bigger. When you're defining a function, you can use x to be the local variable in that line, and it won't graph anything. Okay, it's when then you say y equals the function that it will graph it. So we could use almost any letter that we want. We could use A or B, but x is pretty common, and it won't graph it. It'll just use x as the local variable in that line to be the input. So if you want to, so equals. If you want to build a piecewise function on graphing calculator, so by the way, you're going to have some assignment similar to this. So that's why I'm going through all this. To split it up and do it piecewise, you're going to hit Control A, and on a PC it's Control Shift A. Okay, so Control A, and you notice what happens when I do Control A. It gives me 2 pieces, and then every time I hit Control A after that, it'll add another piece. So how many pieces do we have for the homework? 3. So I'm going to do it one more time. So now I've got my 3 different lines. Okay. Okay, so this is going to begin at the point -7,5 with a constant rate of change of -2/9 for the interval from x equals -7 to -3. What will I put for the rule, my first rule in the piecewise function? -2/9. Times x minus -7. Oh, what the heck? Yeah, agreed. Okay. So plus 5, right? So this was what we worked on last Friday, and in recitation, your homework. We're going to call this point-slope form. Given a point and the slope, this is our point-slope form. But we want to specify that this is only true for x values in this first interval from -7 to 3. So what we could do is write if -7 less than x. Now we're going to use, -3 is our first, what we're going to call the first breakpoint. That's the first point where it changes. So what we'll do is, if we were to put -3 in, we want it to invoke this rule and not the next one. Okay, so we're going to use less than or equal to, and you can get that by doing option less than. So option and then less than sign, so option shift and -3. Yes?
If you wanted it to include that point -3, wouldn't it have been a bracket in that interval notation in the question?
Well, the way that I taught it, it's gonna, both rules are gonna give you the same y value at -3, right?
Okay.
So it just connects. But just for actually setting up the function, we want to tell which line do we want -3 to go to. But the rule should give you the same value for both.
But
Autumn.
later on, it will tell us like if there's like a hole, like this kind of notation to make a hole.
We're never gonna have holes in our graphs. So for what we're doing, there's never be holes in the graphs. We want continuous piecewise functions. So don't worry about holes.
How do you make the greater than or equal to sign?
So on a Mac, it's option and then less than or less than. Makes less than or equal to. So option, shift, and then what, comma or something? Yeah, option, shift, comma, which would be option less than. Okay? So next line, quickly here, what's the rate of change? -5/6. X minus -3
Plus 4.
plus 4 if
-3 is less than
-3 is less than
x is less than or equal to
function less than or equal to 4. Did we get that right? No. So what's the problem with this? So we got one mistake.
F of 1 is 4?
You put the instead of 4, you want to do an x.
Do we have the interval right?
You want to do the greater than or equal to 3. Because you include.
No, we want -3 to no. We want -3 to invoke this rule. We can't invoke both. That's what I was saying before. We're always going to have the right side be included and the left side not be included.
Less than or equal. Oh, you got to do f of 4 plus f of 4.
Yeah. So here's the problem right here. This is not. This is what the y value
It's an x
at the breakpoint. So how can we represent the y value at the breakpoint?
function notation.
And so what function are we going to invoke so that we? So what are we going to invoke so that we get the function value at -3? Piecewise of piecewise of 4? -3. Right? So it's the point slope. This is x minus the x value plus the corresponding y value. And so what will it do when it sees this? It'll go to the function and it'll say, oh, x is -3, so I'm going to evaluate it on this line. And so it'll be the y value at the right end of this interval will be the starting the left y value on this interval. Does it make sense? Okay, last rate of change, 8/7. X minus 4 plus piecewise 4 if 4 less than x less or equal to 9. So do you see what's going on here? Does it make sense? This is our point slope form that we learned. And then we're taking a piece from each of these 3 different constant rate of change functions and specifying it over those particular intervals. So your graph should have looked like, so we're still negatives, yeah, okay. So this won't graph it, this is just defining the function, so to graph it I need to do y equals piecewise. So over 3 different intervals of x, I'm invoking a different constant rate function and we're piecing them all together. And to assure that we get the continuity across the breakpoints, we want the y value from this at the right side to be the y value of the next one on the left side. So they're equal, right? So we're adding the y value here as the starting point of the y value. It's the y value of the ending point of the previous one. Same thing. The ending x value, we'll give a particular y value here. We want that to be the starting y value of the next. Andrew.
Why don't you, for the first interval, why don't you do x is greater than or equal to -7?
You could.
Oh, it just,
I'm just staying consistent.
oh, okay, I see.
Yeah. So it's kind of, you can or you don't have to. Either way. We could. Other questions? Does this make sense with the homework? Yeah, Lauren.
So it might not have been coordinates, but I saw somewhere -7, -3. Where does that come in?
Remember, so that you have to see that those ordered pairs, sometimes that's an interval and sometimes that's a point. So in this case, what was it? -7, -3. What is that? That's an interval. That's a starting x value and a final x value. It's not a point. So sometimes when you see that in parentheses, sometimes it's a point, an x and a y, meaning a point. And sometimes it's an interval, like starting here and ending here. So through the context, you can determine which it is. In this case, it says the interval, -7 and -3. So where's that? That is right here. -7 to -3 is where that first graph lives. That's where the -7 to -3 comes in. Make sense? Other questions on this? Yeah, Christina.
So when you put piecewise -3,
Yeah.
where's like the -3? What's it plugged into exactly? Like,
What is it plugged into? You tell me.
is it just
Plugged into what function?
the second one?
No, so this is all one function, right? This is the piecewise function. So if I was to put, what would happen? If I put, say, 0 into this function, which line is it going to invoke? Which line is it going to invoke? Which line? I put 0 in. 0 in for x. 0 is between -3 and 4, right? So it's going to go to here. It's going to plug 0 into here. And it's going to evaluate this for x equals 0. Okay? So it's going to figure out what that is. And then it's going to come here and it's going to say, oh, but I need to add piecewise of -3. Well, what's that? It's going to put -3 in here. And now where's it going to go?
The one that it started with?
It's going to go up to number 1 and evaluate that at -3. And get that, and it's going to add that to what you had for 0, and that'll be the function value at 0. So does that help? Yeah. So it's using its own function to define itself. The only problem with that is you can't have it call the same line, right? Because then it'll just get stuck in an infinite loop. So this couldn't be piecewise of 0. That wouldn't work because you would just keep looping in the second line and you'd never escape, right? And it wouldn't be defined. So you can invoke another line of the function. That's what we want to do. We want to get that y value on the right side of the first interval to be the y value of the left side of the second. Other questions? Okay, so your assignment is to create like a piecewise generator. So this is a piece, so BP1, BP2, BP3, BP4, those are the breakpoints. Those are the x values where the intervals end and start. And then R1, R2, R3, R4, those are the rates. So yours is going to, your starting value will be 0, and the first breakpoint will be the end of the first interval. Okay? So this is your assignment, so pay attention. There's a lot of confusion on this last semester. So for instance, I want to go from 0 to 5. So my first breakpoint will be 5. Then I want my next interval from 5 to 7. Okay? And then I want my next interval from 7 to 11. and then my next interval from 11 to 18, say. So that just defined the intervals. I just defined them by the breakpoints, you see? And then I have these rates of change. We'll just leave them the way they are. So in the first interval from 0 to 5, the rate of change will be negative 1.5. In the second interval from 5 to 7, the rate of change will be 3, and so etc. According to the numbers I put in, here's that graph. So there's the actual function, that's your part of the project that you have to build so that you can just change the breakpoints, change the rates to whatever you want, and it'll graph the piecewise function. So we could change that first rate to, say, 0.3, and the second rate to 1.2, the third rate to negative 0.4, and leave the fourth rate, push graph, and now it gives us the new piecewise function for that. Okay, I could change breakpoint 1 to be 1 instead of 5. So this is like a piecewise generator. Okay, all you do is put in the breakpoints and the rates, and the program, the file will generate the piecewise function. So it's your job to create this same file that will accomplish the same function. Yeah.
So there's nothing above or below that. We just have the BP 1, 2, 3, 4, and then y equals f of x. Is that how does it graph it?
Yeah, that's what you're doing. That's the part. Your part of the project. Right.
There is more stuff.
What's that?
So our first point it's going to be at the origin.
Yeah, the starting interval will always start at the origin. Yeah. So your breakpoint 1 is some positive value from 0.
This is the homework that's due on Friday?
I think so. Yeah.
Okay.
Friday or Monday.
Do you use those on Blackboard?
Yep, as always. Yep. Yep, it'll be posted. Other questions on this task?
So it's
Yeah.
just going to be, we're going to email you the file. Is that how this is going to
I haven't thought about that yet. I'll let you know.
Okay.
So do you do the backslash again then for the BP 1 for those values?
Yeah, if you need to, so if you're gonna define parameters that are strings, you're gonna need to use the backslash. That's right. Other questions? So here's the deal. You have to define this function f, right? It's behind the curtain. You have to figure out how to define that function f so this thing works. Okay. So this is what we're talking about. We're talking about piecewise linear functions. We have a constant rates of change. They're different over different intervals. And then we're piecing them together, right? We're piecing them together. So you did, okay, so here we go. So when you look at this graph here, what is your thinking about constant rate of change? What do you observe in the context of constant rate of change? What do you observe about this picture here? Josh?
It's positively increasing.
What's that?
It's positive.
What's it? What's positively increasing?
So,
The slope is increasing. Is the slope increasing? No, the slope is constant. So, I want to be specific with our words. So, he said it's increasing, and then he was talking about slope, so...
Y in relation to x is increasing.
What's that?
Y in relation to x is increasing.
Y in relation to x is increasing. Is it increasing constantly?
Yes.
So changes in y proportional to changes in x.
Are changes in y proportional to changes in x here? Okay.
Yes.
Tell me more. Changes in y are proportional to changes in x because we have what kind of rate of change? Constant rate of change. Can you be more specific?
Slope is a relative size of y in relation to x.
Almost.
Or x in relation to y.
No. First was closer, but you still didn't quite have it. Slope is the relation of
Oh, changes.
changes in y to changes in x. changes in y to changes in x. What about this slope? Or what about the relative size of changes in y to changes in x?
About 2 times the size of the
Say it again?
changes in y are about 2 times the size of
He says changes in y are about 2 times the changes in x. So therefore, k is about 2. Yeah, good. The change in y is twice the change in x. But what if I make a really small change in x? Still proportionality, right? Even with a little small change in x, the change in y is still 2 times the change in x. So it's looking like this has a constant rate of change of 2. Changes in y are twice the changes in x. That's the relative size. Change in y to change in x. So I want to introduce a new way to show this. So instead of having the y value here, what if we had the rate of change here of this graph? So instead of tracking the y value for values of x, what if we tracked the rate of change? What would that graph look like?
Straight line, horizontal line.
Straight horizontal line at?
Over certain that
2.
Like that, right? Constant rate of change. So if my y-axis now means the rate of change, for this particular graph, it's just be constant at 2. So as x, for any delta x, we're saying the rate is always constant rate of change, 2. Same constant rate of change over every interval of length x. Okay? And that's exactly the same thing as shown over here on this graph. The relative size of changes in y to changes in x is always 2. Okay, so we're going to start working with rate of change graphs, which don't give us the y value, or the quantity, the second quantity, but the rate of change of that second quantity, graphed as the y coordinate. Okay, so here's one. So here's a rate of change graph. Okay, here's a rate of change graph so this is our notation, the rate of change of f of x. The rate of change is -1 when x is less than 0, and 1 when x is greater than or equal to 0. The question is, can you draw the corresponding function, f? If that's the rate of change function, can you draw the function f? Give it a try. So what would the function f look like if this is its rate of change function? Yeah, what would the function f be like if this is f's rate of change function? Or rate of change graph? So let me see, I'm going to walk around, I want to see. What do you think? So what would a function look like that has that rate profile? Okay. So, okay, right? So we got about 20% success rate here. What does a rate of change of -1? How does that graph as a function if it's always constantly -1? Show with your hand. For a change in x, what's the corresponding change in y?
1.
How will the change in y compare to the change in x if the slope is -1? So I give you a change in x from here to here. What will the change in y be? It'll be that same quantity down, right? It'll be the same amount down. The relative size is -1. The change in y will be the same size as x, but negative. So, right, will look like this. Okay, what about +1?
Increasing.
Okay. So, comments, observations? Something to say, something to add. Daniel.
The graph could be moved up and down as much as you want.
He wants to move the graph up, so I'm going to move the graph up here. Just move the whole thing up. Is it still legitimate?
Yeah.
Yes.
Still has that same rate function, right?
You can't tell the starting point based on the rate of change function.
How about this one? Does it work? Oh, what about this one?
Yeah.
Yes or no? Not technically. Yes or no? Is the rate of change of this modeled by the one on the left?
No. There's a jump.
Well, is there a jump in the rate of change?
But there,
That one's like one, that's a -1, that's a -2.
but there would be a higher growth rate
What?
for that center point there because it jumps from -1 to. It's not constant. I guess depending on it.
This is perfectly legitimate. This is perfectly good. The rate of change is -1. And then suddenly, the rate of change is 1. It's okay. What's that? So, do the actual y values of this graph matter? They don't matter, it's just how it's changing. This only tells us about how it's changing. For every change in x, the change in y is -1. For every change in x, the change in y is 1 of that. And that's exactly what this does. Okay, so any one of those that I showed you, that's totally legit. -1 to 0, -1 rate of change up to 0, and then +1 after 0. Is it okay? All right, so you did some little work about tax tables. So the idea of how we evaluate taxes has everything to do with almost everything we've talked about so far. So this is a really nice example of all these ideas that we've talked about. But before we get into that, we should really understand, how does it compute your tax? So if your salary was $26,420, how do you use this table to get your tax? Autumn.
The first, I don't know how much exactly it is, but the first whatever amount, like say it's like $8,000.
No, how do you just use this? How do you just get how much tax you owe using this table? It's much easier than that. We're getting there. You're just jumping the gun a little bit.
Find your taxable income.
Yeah, you find what range you're in. Aren't we in? This would be in this range right here. And then, so 26,420 is in between these two.
If you're single or married.
Yeah, so you guys mostly are single, so you'd pay this much. Okay, so then, but what Autumn was getting at was, where does this come from? How do you get that number from? Where does this number come from? Where does this number come from? So,
Very large piecewise.
okay, why? So, why is it a very large piecewise function?
Because you have 40 intervals.
What's that?
Because you have 40 intervals.
Well, okay, so you don't have to do a piece for every one of these intervals. Okay.
Change is still the same.
But who knows how our taxes work? Well, how do our taxes work?
The first certain amount, like it's like 8,000 something
Okay.
dollars, is taxed 10%.
Right.
And then you, like, say if you're making $26,000, you would subtract the first $8,000 and tax that 10%. Then the difference would be taxed like 15% or whatever the next interval tax rate is.
Right. So our tax system is called a progressive tax system. So as you make more and more dollars, the rate at which you're taxed at goes up. Okay? So let's see how that works. So here is a piecewise function. It's the tax rate function. So let's analyze it. What's the input? What does X represent? Taxable income. What's the output of this function? Okay, the output is
How much you're paying taxes.
right. It's a tax rate. It's not how much you pay in taxes. It's not.
They're constant. It's not a function.
It's the tax rate for the last dollar that you're going to make. Okay, so if you make $100,000, you put it into this function. What's the output of the function? 0.28. And what that means is that's the rate at which your last dollars are taxed at. The last dollars that you made up to 100,000 are going to be taxed at that rate. That's what this means. Okay, so if you make, say, your annual salary is 100,000, say. Okay. So at the beginning of the year, and this is a year right here, so this is 1 year. At the beginning of the year, how much money have you made? 0, right? You think about you're going to accrue this income across the year. So sometime near the beginning of the year, you're going to hit your 8,300, that dollar right there. And then sometime around maybe April, you're going to hit 34,000. Near the end of the year, who knows, October, November, you're going to hit 82.4. So in that time, at the beginning of the year, when you made your first dollars up to 8,370, those dollars get taxed at what rate? 10%. But then as soon as you make the next dollar after 83.70, all those dollars are 15%. And then after 34,000 up to 82, those dollars that you made through the middle of the year, 25, and then after 82 to the end of the year, 28%.
So just the dollars inside those brackets get taxed at.
Yeah, so these dollars, you pay 10% tax on those. These dollars here, you pay 15% on those. These through the whole middle of the year, you're paying 25% on those. And then at the end of the year, those you pay 28. Make sense? All right, so how is it that this is a rate of change? So this number, say 0.33. So apply our understanding of rate of change. How is that number a rate of change? What you thinking, Stanley?
It's relative size of the actual taxes you're paying to how much you would earn.
He said the relative size of the taxes that you pay to what you're earning. What do you think? So if you earn $1, you pay 33 cents. So at that rate, it's the relative size of the tax you pay to what you earn.
Earn another dollar on top of what you already have.
What's that?
If you earn another dollar on top of what you already have, like that's gonna be the rate for that $1.
Okay. Yeah.
Unless you, I guess, if you shift them.
But what if I make $10? So now that's like delta x equals $10. How does 0.33 come into that then? So delta x is 10. I'm going to make 10 more dollars. So how much more tax do I owe? K times delta x. Remember this? K times delta x. 0.33. So it's the relative size, so now it's how much tax I pay on $10, which would be $3.30. So the relative size is maintained. Okay, should make sense. Delta y is k times delta x. Any questions on that? So that's how those are rates. It's the relative size of additional income to, additional tax owed to additional income. Delta y to delta x. Okay, here's another function. What's the input of this one?
The actual amount.
The total income, taxable income.
It's still the same thing, taxable income. Output.
The amount of dollars you're paying in tax.
Total tax due, or total tax owed. Okay, so looking at one line of this piecewise function, what do you see? So let's just pick this one. What do you observe, or what you're thinking about when you look at that? What do you think? What do you observe? So I'm not asking about specific numbers. I'm asking about the form.
Looks like what we did.
Corey.
I just saying it looks like what we did for our homework.
Looks like what we did for our homework. Andrew.
That's going to determine your total tax due because that's taking into account the fact that you're not taxing the previous portions
Okay.
at that current tax rate.
Okay.
So year's worth.
Okay, so it will give you your total tax due for a value between these two. I'd imagine.
That when it has that the value of the tax function at 82,400, it's going to jump up to the equation before it, and then when it's in that one, that 34,000 is going to jump up to the equation before that.
Right, we talked about that earlier. Exactly.
But it's like more than one time. It's going to go up each individual piece.
Right.
But it's going to take out the tax due.
Okay, so you guys you're getting into the details too soon. We're getting there. So what's the form of this? What's the form of this? It's point slow form, isn't it? It's this form. Well, everything you're saying is great. Just don't want to jump ahead. Okay. So that's the form of this, right? It's our point slow form. Rate of change, x minus starting value of x plus corresponding value of y. So let's break this down. What is represented by x minus 3,400?
Portion of your income that needs to be taxed at 8.25 rate.
He said that value right there is the portion of your income that's taxed at 0.25. Where's Katie? Katie? What do you think about that? X minus 34,000. Did you hear what he said? He said the portion of your income that's taxed at the 25% rate. Agree with that? Adelaide agrees. Savannah? Yeah, because if you made $50,000, what would that be? 50,000 minus 34,000 would be how much? 16,000. And that right there would be 16,000. And then we're going to multiply it by 0.25. So right, that's the taxable income at the current rate. Okay, what is this? The whole thing. Or just this part right here. 0.25 times that. Somebody new. Yeah, Lauren.
It's how much is taxed from you, or like how much you owe
Tax owe on,
on just that bracket.
right, at tax owed at the 25% rate.
What was your question?
What's that?
What was the question?
Question was, what's represented by what's in red here? or this thing here. Okay, so isn't x minus 34,000, isn't that just like, how can we represent that? Is it an x? It's a change in x, right? And then what is this? The change in y is our rate times the change in x, see? And then finally, why do we add tax of 34,000? To get the total tax you owe, because all those dollars up to 34,000, they got taxed at 15%. So we need to come up to this line, and this would calculate all the tax owed on 34,000. We add that to the new tax at 25%, and that will give you your total tax owed. Okay? But you see all these ideas we've talked about so far. Rate of change, piecewise linear function, it's all here. Okay? So this is a really nice example to work on this, and then we're knocking on the door of calculus now. Okay? We're almost there. We're almost there. Okay? I'll post homework for Friday.
It's due on Friday?
Yes, it's due on Friday.
Yeah. I'll probably post the video.
This video? I tried to do it this afternoon.
I want to watch it right now.
Were you calling him by Andrew? Because my name's Connor.
I'm sorry.
Oh, no problem. I was just
Totally, because no, that's Andrew. You guys look alike, and you sit over there together.
Okay, yeah, because
Sorry, dude.
Oh, no problem. I was like, is he calling me?